About linear functions, and I'm pretty confident you guys will feel very good about this since this is all just a review from your days in Algebra 1. All right, so kind of the first thing that we talk about is a linear function, which is defined as a function with a constant rate of change. All right, it's a polynomial that has a degree of 1, so like x to the first power. All right, and we can show several different ways with tables, functions, graphically, things like that. So we have an example here of a train traveling a long distance and maintains a constant speed of 83 meters per second for the period of time once it hits 250 meters from the train station. So it's like probably got to accelerate or go maybe a little slower while it's closer to the train station, maybe a little more traffic on the tracks. But once it reaches a distance that's far enough away, it can then cruise at that 83 meters per second. I could use an example of like driving on a road trip. If you have cruise control in your car, once you get to that place where you're kind of out of the city and you're not having, stop signs or stoplights, you can hit that cruise function and then not worry about, having to adjust your speed. All right, so the train's distance from the station is a function of the time during which the train moves at a constant speed plus that extra distance, or you could have said like buffer distance from the station when it began moving at that constant speed. All right. Now, you guys know that models a linear function. All right. So one example of a notation that you've used in the past is the slope-intercept form of a line. So we'll be talking about using that form again. And I guarantee you have that memorized, where x is the input value, m is the rate of change or the slope, and y is the initial value of the dependent variable. All right. So in the example for the train, right, if we want to make a table based on the scenario that they gave us, all right, so if time is in, I think it's seconds, I'll confirm. Yes. So if time is in seconds and the distance is in meters, all right, because this function is starting 250 meters from the station, I actually have to put that when time is 0, even though we know the train has been going for a little while, at time 0 for this particular function, we must say that it's 250 meters. Then 1 second from there, we're going to add that constant rate of change, or that slope, of 83 meters per second. So 83 plus 250 will give us 333 meters. Keep doing the same thing for each second. Add another 83, you get 416 meters. And one more time, 499 meters. Okay, so the little blurb here at the end of the page is just asking you to think that if you're talking about scenarios that involve things that could happen out in the world, that you think about what makes sense. In this case, we're talking about time, all right, and we're only thinking about positive numbers for time. We're not going to have negative numbers for time, can't go back in time. So in this case, we're thinking about only positives for our inputs. Okay, so in terms of representing this as a graph, all right, we will always show this if it is a linear function. The graph will always show a line. That rate of change, which we've talked about, is the slant or slope of the line. And the point at which the input value is 0 is the vertical intercept, which you guys know as the y-intercept of that line. So in this scenario of the train, all right, we're starting at 0, 250, right? We have to get 250 meters away from the train station before we start this function. Then each additional second, we add on that slope of 83 meters. So it's like 333, it was like 416, and then essentially 500. Probably not going to be a perfect line here, but in theory, it should be right if I were to sketch this in a calculator. All right. Notice how I don't have an arrow going to the left of 0, as we already talked about. Time is only going to be that positive values. Okay. Okay. So now let's talk a little bit about this idea of interpreting what these functions might be. All right. They give us an example here where the pressure, capital P in pounds per square inch, or PSI, on a diver, depends upon her depth in the water, which is d in feet. So they've given us the function that models this, and it wants us to essentially interpret it. So when I do this, I always interpret. So I'm going to write that I interpret the y-intercept and the slope. So I do that. I do these in 2 steps. Some people will do it in 1 step. I like to do 2 separate sentences. It's easier for my brain to understand what's going on with these 2 different components of the function. And also, if you're in stats class with me as well, you're going to see that this is the same approach that we use for linear modeling in stats. So it's really, I think, a good way to view it because it can help you in other disciplines as well. So let's start with the y-intercept. So the y-intercept, without context, is that when your input is 0, your y output value is the y-intercept. So now I'm going to say that whole thing, but in context for this problem. So at 0 feet under the surface, all right, so I guess I should say under the water surface, the pressure on the diver is 14.696 psi. Now, I've never been diving. I don't know anything about diving, just to tell you that right now. So I don't actually know if this makes sense or not. Like, is there a way that with all that gear or with like gravity of the earth, that before this diver even gets under the water, they're experiencing that much pressure? It may be true. I don't know. I don't know anything about diving or the science behind this. But there's also a chance that this could be meaningless, right? Especially if you're in my stats class, you recognize that some y-intercepts they don't really help us say anything. So, but I always write it just in case it is going to give us some meaning. Let's do the slope. So for each additional, let me say this without context first, okay? So interpreting the slope with no context is for every 1 unit that you increase your input value or your x value, your y value is going to increase or decrease by the slope, depending on if the slope is positive or negative. So in this case, for each additional 1 foot the diver moves, as I'll say, moves under the water, I expect the pressure on the diver to increase by 0.434 psi. All right, so that's what I say when I want to interpret the components of a linear function. Okay, so now let's talk about the slope formula. Again, another formula that I'm pretty confident that you have memorized. This is y subscript 2 minus y sub 1 over x sub 2 minus x sub 1. I will ask you if you're saying y2 minus y1 to include that sub or subscript so we know that it represents a different ordered pair. All right, another way to think of this is your change in y over your change in x, okay? Now, in terms of determining whether a linear function is increasing, decreasing, or constant. So the graph of an increasing function has a positive slope, all right? And you probably thought of this when you were in middle school as slanting uphill from left to right. A decreasing function, the slope is negative. And when you look at the actual graph, it's going to slant downhill from left to right. All right, lots of different things out there on the internet that can help you understand positive and negative slopes. So I've given you a few graphical displays here in this figure where you have in letter A, we have a positive slope, so it's increasing. B is a negative slope, so it's decreasing. And then C, which has no slope, is a constant function. So in this case, whenever you see that horizontal line, you want to be thinking no slope. All right, so a couple of different scenarios here that can help us sketch these. I'll start with letter A. All right, so letter A, we have the total number of texts a teen sends is considered a function of time in days. So we've got total texts and then days. Okay, so as the number of days increases, I would expect the total number of texts to also increase because we're just accumulating. So I'm not sure what would be like the y-intercept, but it would definitely have a positive slope. Letter B. They changed the scenario slightly this time to say that a teen has a limit of 500 texts per month. All right, so the output is the total text, and this is key here, remaining, right? So remaining means we're starting at 500 up here, and as we increase the days and this teen sends text messages, that number is going to go down. And we're going to assume it goes down at a constant rate each day. Probably not true. All right, C, the last one. A teen has an unlimited number of texts for his or her data plan that always costs $50 a month. So the input is the number of days again, and the output is the total cost. So total cost. And so it doesn't matter if she or he sends 5 texts or 5,000. It's always going to be that same cost. So this one would have no slope and be that constant $50 per month. Okay, so now in terms of looking at how to find these values, if they give you a graphical display like this on the left, right, you can always just count your rise over run, right? They put that here. The change in y over the change in x is also can be interpreted as rise over run. So you can always do that. Just keep in mind that if you're counting up or you're going in a positive direction and counting down a negative. Same thing with going right is positive, going left is negative. So always be aware that the signs do matter. All right, but a lot of times they're just going to give you 2 points. And if they give you 2 points, then you can actually find the slope. So I'm going to find the slope here, where I'm going to use this as my x subscript 1 and y subscript 1. And this is my x subscript 2 and my y subscript 2. So for my slope formula, I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1 and plug in my stuff. So 1 minus negative 2 over 8 minus 3. You learned a long time ago in middle school that subtracting a negative is just addition. So 1 plus 2 is 3, and then 8 minus 3 is 5. All right, now that is the slope of this line. And then it says, is the function increasing or decreasing? And as we just spoke about a few minutes ago, if you have a positive slope, then the function is going to be increasing. All right, let's talk about this population of a small town. So it increased from 1,442 to 1,868 people between these 3 years, 2009 to 2012. Find the change in population per year if we assume, so big assumption here, that the change was constant. So I'm going to do my ordered pairs as 2009, there were 1,442 people, and 2012, there were 1,868 people. So same idea. If I use my slope formula, I can figure out the average, my change in population per year if we're assuming this is the same each year. So we have 1868, that's not a year, that's number of people, minus 1442 over my change in my time, which is 2012 minus 2009. So 1868 minus 1442, let's see if I can get that for you. 1868 is 426. All right, and that's over 3 years. So if I want it per year, we're saying 142 people per year. Okay, let's go to another formula you should remember from your days in Algebra 1, which is the point slope formula. And this is important. You may not have heard this yet or know about this yet, but you are in pre-calculus, all right? And so the hope is that you have some interest potentially in college in taking calculus, and you will be expected, and it is important to know the point slope formula that's going to be part of the work you do to find tangent lines to different functions. So, a lot of times you learn something when you're younger that you don't really see, how it kind of plays out and why you're learning it. But that is the reason why you need to know point slope formula. So make sure you know that one, have that memorized. Already talked about slope intercept form. All right, so let's use our understanding of that to write this function 2 ways, one in point slope form and the other in slope intercept form. So I'm going to start with point slope form, which I need a point, I see 2 of them, and I need a slope. So let's find the slope, the change in y over the change in x. So I'm going to do my 4 minus 7, which is my change in y's, over 4 minus 0. That's going to be negative 3/4. You could have also, if you wanted to, you could have also counted this on the graph. They are giving you a graphical display. So if I count my rise, which is actually down, so this would be 1, 2, 3 down, so negative 3. And my run is 1, 2, 3, 4 to the right. That would be my negative 3/4. So you can do it by using the graph too, if that works for you. Now, in terms of writing this in point slope form, all right, which is y minus y sub 1 equals m times x minus x sub 1. I'm going to use my slope and pick a point, and I'm going to choose this 4, 4. So I have y minus 4 equals negative 3/4 times x minus 4. Now, if this was a question where it said write in a point slope form, you'd just be done, right? This is point slope form, so I'm finished with that. But it also tells me I want to do this in slope intercept form. Now, there's a couple ways you could go from here. If you wanted to, you could take your point slope form, because you're actually, I guess I should write slope intercept. You're very close to slope intercept when you have it in point slope form. You could distribute the negative 3/4 and then move this minus 4 that's with the y to the other side. Totally fine. Absolutely could do that. But the thing I noticed about this is that it actually, one of the points was my y-intercept. So now that I have my slope and I know the y-intercept, I can go ahead and just write this as the answer. So y equals mx plus b. So y equals negative 3/4, right? That's the slope, x plus 7. All right. And I know that in your time in Algebra 1, you would have used that strategy to use your point slope form to eventually get to slope intercept form. All right, let's do a couple of problems that are very similar to this using that understanding. So this says Ben starts a company in which he has a fixed cost of $12.50 per month for overhead. That includes his rent. His production costs are $37.50 per item. So write a function c of x, so c of x, for the cost for him to produce x items in a given month. Well, we know the fixed cost, right? No matter how many items Ben actually produces, is $12.50 a month, right? But per item, which is our slope, is $37.50. So that's where I put my slope as my mx, or excuse me, my m, and I'm going to put x, right? Because it says that's the input, that's the number of items produced in a given month. So if they told me that he produced 10, I would substitute 10 for x. I can find the total cost. If they produced 100, same idea. So this right here answers this question. Okay, they're giving us a linear function f of x, and f of 2 is negative 11. So that'd be like if you plugged in 2 for the x, you got negative 11. And if you plugged in 4, you get negative 25. So write the equation in slope intercept form. All right, so what I'm going to do here is, since I have 2 points, I'm going to find the slope. So the change in y over the change in x. So negative 25 minus negative 11 over 4 minus 2. So again, subtracting a negative becomes addition. So that's negative 14. And 4 minus 2 is 2. So my slope is negative 7. All right. Now it says it wants it in slope-intercept form. Neither of the points that I have are the actual intercept. So you've got a couple options here how you want to do it. What your teacher in Algebra 1 probably taught you to use is use point slope form as like a bridge to get to the slope intercept form. So that y minus y subscript 1 equals m times x minus x subscript 1. You've got 2 options here. I'm just going to choose the first point. So y minus negative 11 equals negative 7 times x minus 2. I'm going to change that to be addition. Now I'm going to pause for a second and just make sure you understand that right here is point slope form. So it's one of those things where everything I do after this, I'm not changing the actual function. I'm just changing kind of what it looks like. I like to use this example a lot in our school, is that like if you're in your uniform on Monday and Monday is not a work day, you can wear a polo All right, so let's say that's your point slope form, but then when you go to work on Tuesday, you've got to wear your uniform, so you look differently, but still you. So that's like your slope intercept forms. So even though you might look a little different based on the clothing you're wearing, it is still the same thing. All right, so let's distribute the -7, which is -7x plus 14. Move the 11 over with subtraction, and you get +3. So this is our answer in slope intercept form. But I want your brain to know that if I were to graph these, and I guess I can show you if I wanted to, take a minute to do it. If I were to graph these using a graphing calculator, it would show me the exact same lines. Let's go ahead and show you that. So you don't just like take my word for it, you can actually see it. So I'll do the answer, -7x plus 3 first. Okay, so -7x plus 3. So there's the line. And then the other one is a little bit more difficult to write. Y plus 11 equals -7 times x minus, was it 2, I think? Yes, must be, because it's the same. Yep, and if you look, if I take that away, let me take the other one away. You can see the red still there. And if I take the blue one away, it's still there. You get the idea that they're the exact same line. All right? Okay, let's keep going. So a few real life possibilities of seeing this occur with our linear functions. We've got an insurance person, Ilya, earning a base salary of, we don't know, so we gotta find. We're base salary plus a commission. All right, so Ilya's weekly income I depends on the number of new policies that he sells. Last week he sold 3 policies, so I'll go ahead and write that down as my ordered pair. So 3 is my input and earned $760. And then the week before that, he sold 5 policies and earned $920. Again, remember those Y values, those salaries that he actually earned, right, tells you that in that number, there is a base salary plus a commission for selling more stuff, okay? So, or more insurance policies. We have I of n, and we need to find this slope intercept form. So I'm going, I'm going to put in slope intercept, but you can use either one. So I'm going to find the slope first, right? The change in y over our change in x. So I have 920 minus 760 over 5 minus 3, which is going to be 160 over 2, which is $80 per policy. All right, or I guess I should say $80 per week. So in this case, I'm going to choose that to be my slope, where Ilya is going to get $80 for each additional policy that he sells in a week. All right, so that's going to be my slope. So now you could use point slope form because you have either option here, right? Here's point number 1, here's point number 2. But I actually want to show you a different way to do it. If I write down my slope intercept form, right, I know the slope is 80, right? And if I choose my first one, my first ordered pair, my x is 3. I don't know my y-intercept, that's what I'm solving. And I know that he made $760. So I have an equation with one unknown. I can go ahead and solve for this unknown, letter b. So that's 760 equals 240 plus b. So b equals, what's that, 520, I think? Yes. So when I write down my answer, I'm going to write down this I of n equals 80 times n, right? N being the number of insurance policies that he sells, plus his weekly salary, no matter if he sells none, of $520. Again, I just want to show you options here. The work that I did, I'll highlight it, right? This work that I did right here, you could have used point slope form and algebra to get to the same answer. Your choice. All right, let's do another 2 and then we'll be done. Now, this one, when they give you the table, what I like to do when it says to write the function, I'm going to use slope intercept. And if they give me this ordered pair of 0, 1,000, that to me is the y-intercept. So all I need to do is find the slope. You can do the algebra if you want, but in my mind, why not just use your ability to do subtraction, right? And this distance here, right, is 2 weeks, and this distance here is 80 rats. So if I want to get that slope to be per 1 week, I just divide my 80 over 2, right? My change in my y over the change in x. So this slope will be 40. So to write my answer as P of W, so the population of rats per week, is going to be 40 times W plus the population started at 1,000 rats. That's a lot of rats. I don't want to think about that. So there's our answer. Let's do one more. We've got a young tree, and they're introducing new plant food to see what happens to the growth each month. So again, like I said before, right, that first ordered pair of 0, 12.5 gives me my y-intercept. And in this case, that means our young tree is 12.5 feet tall. And this distance is 2. This is going to be 1. Remember, divide the y over the x, so it's 1/2. So it gives me 0.5x plus 12.5. So we're saying that the tree starts at 12.5 feet, and each additional month, I expect the tree to grow by 6 inches or 1/2 foot. All right, so that's it for linear functions. Don't forget to try the practice problems.